Good morning Year 6 and welcome to Thursday's math lesson. Okay, the learning focus for today is I can use algebraic notation to form one-step equations. So we're going to be building on our formula work from yesterday. Okay, first up is the flashback 4. Have a go at these and pause the video. Okay, number 1. Use the formula A equals LW to work out the value of A when L equals 6 and W equals 8. Well, we know in algebra, when there's two algebraic symbols with nothing in between, then it's going to automatically mean multiplication. So this means, so here to work out A, we need to do 6 multiplied by 8, which is 48. Number 2, what might the rule be for this function machine? 12 goes in as the input and 36 comes out. So we could see it could be simple multiplication, multiplied by 3, or it could be add 24. Number 3, write 2/5 as a decimal. Okay, well we know that 1/5 as a decimal is 0.2, so therefore 2/5 will be 0.4. Number 4, divide 2,394 by 7. We can use some short division to get the answer of 342. Okay, well done if you got all of those right. Okay, question 1. So, our learning focus, as I said, is using algebraic notation, and today we're going to be creating our own equations. Okay, you might find some of this tricky today, so please don't be afraid to pause it, think about it as much as you like, and then maybe go back and review it and listen to it again if you need a little bit more clarification. Okay, so we will be building on the earlier step of forming expressions, and we will be using algebraic notation to form one-step equations. So today you will learn the difference between an expression like x plus 5, which can take different values depending on the value of x, so you can input different things in there, and an equation like x plus 5 equals 11.2. where x is a specific unknown value. A little bit like the example that's on the top right hand side of the page, x plus 2 equals 5, that's where x is a specific unknown value, 3 in that case. I'm going to show you pictures of cubes to represent the unknown values and counters or little stars to be used to represent the known numbers. Now you need to go back to those images to help you understand if you were tool stuck. Okay, so here's the first example. So Amir represents a word problem using cubes, counters and algebra. So he's got his words that are being said, the actual question in the first column. He's then got a concrete example, so he's actually using cubes and counters, or cubes in this case, to help him work it out. And then he's got the algebra, how he'd write that as algebra in the third column. And we're going to have a go at doing the same thing. So I don't know if you've got anything at home. You could use like 2p's and 1p's, so 2p's to represent one variable and 1p's, anything you've got at home to represent this. Try and actually to do it and then draw pictures in a grid, or draw pictures in your book to help. So we need to complete this table using Amir's method. So have a little go at this and pause the video. Okay, so I think of a number. So I'm going to call my number x, and I'm going to represent it with a cube. I'm then going to add 1 to my number. So I've still got my number, and I've got one little cube as a little star that I've used. And as algebra, that would be x plus 1. But now we're actually going to put a value to the answer there. So now x has a specific value. So my answer is 8, he says. So here I've shown you, I've got the cube, or the x plus 1 equals 8. So there, in this example here, you can see all these stars or suns, whatever they are, that if x plus 1 equals 8, then there's the 1. If we take away the 1, then we're left with 7. So the x must be equal 7 in this example. Just like in the example above, x plus 3 equals 5. The actual x unknown must have equaled 2. Okay, moving that forward. So, in this question, A book costs £5 and a magazine costs £N. So we don't know how much the magazine costs. The total cost of the book and the magazine together is £8. Write this information as an equation using the same method that we just used in the previous slide. Okay, pause the video now. Okay, so we know that £N, we're going to call the cost of the magazine £N. So we could call that N. And then the book costs £5, so we add 5, and then together they cost £8. So N plus 5 equals 8 would be how we would write that as an equation. Second question. Write down algebraic equations for these word problems. Okay, so number 1, I think of a number, subtract 17, and my answer is 20. I think of a number, multiply by 5, my answer is 45. Okay, very similar to that first section we saw with the table, but just don't forget what to do when, or how to write an algebraic expression when we're multiplying. Okay, pause the video now, please. Okay, now I think of a number. You can call that anything. You might call that X, you might call that N, you might call that A, up to you what you call that. I called it X. So here I think of a number X, I subtract 17, and my answer is 20. That's how I'd write it as an equation. The second one, I think of a number again, X, I multiply it by 5. I remember to write that as 5X, well, and then my answer is 45. That's how we write it as an equation. Well done if you've got those ones right. Okay, on to the next question. So Rosie thinks of a number, she adds 7 and divides her answer by 2. Teddy thinks of a number, he multiplies by 3 and subtracts 4. Rosie and Teddy think of the same number. Rosie's answer is 9, so what is Teddy's answer? So here we need to input the information that we know. So we know we can make Rosie's sentence into an algebraic equation, and then we can put the missing bit of information in there. Okay, apologies for making that all appear at once. I should have done that a step at a time. So using the arrow, hopefully you can see the arrow on your screen. So I've got here, Rosie thinks of a number and adds 7. So I've called the unknown number X. So X plus 7. And then it says she divides her answer by 2. So I've put the X plus 7 in brackets and I've divided it by 2 to give me an answer of 9. Under here in blue is actually how you would write that in algebraic terms. So with divide, I think I've said this before, but when you write divide, you actually write it like maybe you would in a fraction. So you just put a line and you put it underneath, and that there shows that that's the X plus 7, all of that being divided by 2. Okay, so let's input some values in there. So we need to work back to find what X was. So we're going to do the inverse, just like we did with the function machine. So if we know X plus 7 divided by 2 is 9, then we can work back. We start with our 9, we do the inverse. So 9 multiplied by 2 gives us a midpoint of 18. We then had to add 7 to our X to get 18. So if we subtract 7, do the opposite, we're going to find out that X is 11. Now we know that X is 11, we can then input that into Teddy's algebraic formula, 3x minus, which was 3x minus 4. It was 3 times x minus 4, and we can work out what his answer is. So we know that x stands for 11, so 3 times 11 is 33. We subtract 4, which gives us an answer of 29. Okay. Now this time, Rosie and Teddy think of the same number again. This time they both get the same answer. So they get the same answer when they've inputted a number into their equation. Now, use trial and improvement to find the number they were thinking of. So here, we need to think of a sensible number to input in. Or if we can't think of a sensible number, just try with a number. And then what happens if you see if your answer is way out or not, and then you adjust your answer accordingly. So I'm looking at the fact that the number input was 11 that we used previously. And when we used 11, the answers were wildly different. So I think I'm going to start with quite a lower number and see how I get on there. I'm going to start with 2, I think, first of all. So I'm going to try it out with 2. Again, apologies, it's all come up at once for some reason. Okay, so I'm going to input 2. So I'm pointing with my finger, that doesn't help, does it? I need to point with the mouse. So x plus 2 is 9. 9 divided by 2 is 45. So here Rosie gets an answer of, 4.5. If I then inputted 2 into Teddy's, let's see what I get. 3 times 2 is 6, minus 4 is 2. So there, Rosie answers is 4.5 and Teddy's answers is 2. They're not got the same answer, but look, we're going in the right direction because the numbers are getting closer together. So let's try something around there. So let's try 3 this time. 1 wouldn't work, so let's try 3. Okay, so 3, yeah, try it out. 3 plus 7 is 10, divided by 2 is 5. 3 times 5 is 15, minus 4 is 11. So it works for both of those. So T equals 5 there. For Teddy, that meant. His answer is 5. Okay. Eva spends 92 pence on yo-yos and sweets. She buys Y yo-yos costing 11p and S sweets costing 4p. Can you write an equation to represent what Eva has bought? How many yo-yos and sweets could Eva have bought? Okay, have a look at this question and then pause the video, please. Right, quite a tricky one. Okay, so here we need to, first of all, work out what the equation might be. So we know that she's got that the yo-yo's Y cost 11 pence. So that will be 11 times Y, or 11Y, we'd write that as. And you know that she has S sweets costing 4p. So that's 4 lots of S. So here 92 equals 11Y plus 4S, where 11Y is Y times 11 and 4S is S times 4. Okay, so now we need to work out how many yo-yos and sweets could Eva have bought. Now this is where we need to look at the numbers in the question. So we've got an 11 and we've got a 4. So here, now let's look at this 11 and let's look at the 92. So we know it's going to be something in the 11 times table. And we've got something here times by 4, but we need to get to a target number of 92. Hopefully you might realise that if we just made S1 with 4, then we'd have to get 92 take 4. 4 would be 88. We'd have to get 88 here. So we could then see that Y could be 8. 11 times 8 is 88. And S could be 1. 4 times 1 is 4. Okay, another example could have been, if you looked at it differently, seeing that 92 could be made from 44 and 48, where the Y would be 4. 11 times Y is 44. And the S would be 12, where 4 times 12 is 48. So Y equals 4, S equals 12. Okay, now again, a tricky one. Can you write a similar word problem to that previous word problem to describe this equation? Now I'll give you a little hint. You really have to work out roughly what the values of the T and M are going to be. So you probably need to work the calculation out first, work the equation out first, work out the value of T and M first, so that you can put a proper word problem to it. Because if you don't know the value of T, then you might be using, amounts that are way out and don't fit with the problem. Okay, have a go at this one and pause the video, please. Okay, so using the advice that I gave you, I tried to work out the problem. So I know that I'm going to a target number of 74 and I've got the number 15 and I've got the number 2. So I'm looking at the fact that if I need to I'm going to be going up in the 15 times table. So 4 times 15 is actually 60. And that would only leave me with 14. So then M could be 7. So I know that my T is going to equal 4 and my M is going to equal 7. So I'm looking for items that are going to be £4 and I'm looking for items that are going to be £7. So I've thought about that. Well, I've thought, okay, I can buy some meter sticks for £4 maybe and some scientific calculators for £7. Now I know what the value of the amount is, I can input it into a question. So my question was, Mrs. Smith spends £74 buying school math supplies. She buys 15 metre sticks and 2 scientific calculators. How many metre sticks and scientific calculators can she buy? Okay, well done if you came up with a similar question. Maybe try it out on somebody at home. Right, now have a go at the white rose questions, and I'll speak to you tomorrow.